Have you ever really thought about how the internet actually works? I mean, really? Today we're going to pull back the curtain on something called the OSI model. It's kind of like the hidden rulebook that powers everything you do online, from sending an email to streaming a movie. Let's dive in.
Seriously, think about it for a second. You hit send on an email, and poof, seconds later it just appears on a screen maybe thousands of miles away. It feels like magic, doesn't it? But it's not. It's actually a super organized, standardized process, and that process is exactly what we're going to break down today.
So, here's the game plan. First, we'll get a handle on what the OSI model even is. Then, we're going to use a simple analogy, a digital postal service, to follow our data as it gets prepped like a letter and then shipped across the internet. And of course, we'll wrap it all up with a quick recap to make sure it all clicks.
Okay, let's get into it. What is the OSI model? Well, at its heart, you can think of it as the universal rulebook for all digital communication. It's the reason that devices made by totally different companies can all speak the same language online.
So, the OSI model is a 7-layer framework. And its whole purpose, its entire reason for being, is to make sure a Mac can talk to a Windows PC, which can talk to a Linux server, without any hiccups or compatibility issues. It's basically the universal language that allows for this open, seamless communication between any two systems on a network.
Now, I know what you're thinking. A 7-layer conceptual framework sounds, well, a little complicated. So to make this all super simple and clear, we're going to use an analogy that I think we can all get behind, the good old postal service.
The idea is pretty straightforward, right? The OSI model is really just the internet's own postal system. Just like sending a physical letter requires a whole series of steps, sending data online follows a very similar, layered process.
I mean, think about how you mail a letter. First, you actually write the thing. Then you have to package it up in an envelope, write the correct address on the front, and finally, you hand it over to the postal service to get it shipped. Keep these steps in your head because they map almost perfectly to how the OSI model works.
All right, let's start with the very first part of the journey, preparing your digital letter. This is where the top 3 layers of the OSI model come in. These are the ones that are closest to you, the user.
So, these first 3 layers are all about getting your message ready to go. The application layer is where you create it. The presentation layer gets it into the right format and makes it secure. And the session layer, well, it opens the line of communication. Let's break down what each one actually does.
Okay, layer 7. This is the one you see and interact with every single day. It's your web browser using HTTP to grab websites, it's your email app using SMTP to send mail, or a program using FTP to move files around. In our postal analogy, this is you sitting down and actually writing the letter, creating the data that needs to be sent.
Next up, layer 6. You can think of this one as a universal translator. It takes the data from layer 7 and makes absolutely sure the computer on the other end can understand it. It also handles really important stuff like encryption for security and compression to make the file smaller so it sends faster. This is kind of like making sure your letter is written in a language your friend can actually read.
And then we have layer 5, the conversation manager. Its job is to open up the communication channel, keep it open for the whole conversation, and then close it when you're done. You've actually seen this in action. Ever had your Wi-Fi drop during a big download, but when you reconnect, it just picks up right where it left off? Yep, that's the session layer at work, managing that connection for you.
Okay, so our digital letter is written, it's translated, and the communication line is open. Now it's time to actually ship the thing. And this is the job of the bottom 4 layers, the ones that handle all the nuts and bolts of getting your data from point A to point B.
These 4 layers are basically the shipping department of the internet. They take your prepared data, chop it up for the journey, figure out the best way to get it there, handle all the local handoffs, and finally, turn it into physical signals for travel.
The transport layer, layer 4, is incredibly important. It takes your big chunk of data and chops it up into smaller, more manageable pieces that we call segments. But it also does something else that's critical. It makes sure all those little pieces arrive correctly. If a segment gets lost along the way, this layer actually requests for it to be sent again. It's like the quality control manager.
And here's where things get really clever. Layer 4 gives us 2 main choices for delivery. First, there's TCP. Think of TCP as registered mail. It checks to make sure every single piece arrives and in the right order. It's perfect for things like email or loading a website. Then you've got UDP. UDP is more like regular mail. It's way faster, but it doesn't double-check for errors. This is what you want for video streaming or online gaming, where speed is everything, and a few lost pixels here and there don't matter as much.
So layer 3 is the master navigator of the entire internet. This is where routing happens. It looks at the destination IP address, which is just like the home address on your envelope, and it figures out the most efficient path for your data, now called packets, to take across the huge, complex network of the internet. Okay, so if the network layer handles the big, global journey, the data link layer handles the local, step-by-step delivery. It uses a physical MAC address, that's a unique ID that's literally burned into your device's network card, to get the data, which we now call frames, from your computer to your router, and then from that router to the next one, and so on and so on.
And finally, we hit the physical world. Layer 1 is the actual hardware you can touch, the Ethernet cables, the fiber optics, the Wi-Fi signals buzzing through the air. It takes those digital frames, converts them into bits, just raw zeros and ones, and sends them out as electrical signals or tiny pulses of light. This is the moment your data truly begins its physical journey.
So how does this all work together? Well, as your data travels down from layer 7 all the way to layer 1, each layer wraps it in its own digital header. This whole process is called encapsulation. The best way to think of it is like putting your letter in an envelope at layer 4, then putting that envelope in a shipping box with an IP address at layer 3. When it gets to the other side, the receiving computer just unwraps all these layers in reverse to read the message. Simple.
Ooh, we have covered a lot of ground, haven't we? We've got all the way from your web browser down to the physical wires. So let's do a really quick recap just to put it all together one last time.
And there it is, the entire journey, all on one slide. We start up at layer 7, the application layer, where you, the user, create your data. It then travels down through each layer, getting packaged and addressed and sorted until it finally hits layer 1, the physical layer, where it becomes actual bits on a wire. Each layer has a very specific job, and each one is absolutely crucial to the whole process. This is the fundamental blueprint for all modern networking. So yeah, while you'll never actually see the OSI model, trust me, it's working tirelessly behind the scenes with every single click, every stream, and every email you send. It's this silent, logical, and universal agreement that makes our totally interconnected digital world even possible. And that kind of leaves us with a final thought to chew on. Without this incredibly complex 7-layer system to deliver our data flawlessly across the globe in seconds, would our messages even matter? It's a fascinating question, right? The relationship between the stuff we create and the hidden infrastructure that carries it. Thanks for joining me for this one.